All right, so now we're going to take that idea, like we were working on surface area and volume, and then we're taking the idea of how we used to take the area of the whole thing and then like subtract out the middle section, like the shaded part that we did in the last example in the last video. So now we're going to move that to the idea of a prism. So it says a child's toy is constructed by cutting a right triangular prism out of a right rectangular prism. So basically we have this like box type thing, right? And there's a triangular piece missing out of all of it. It's not just one triangle, right? It's got some height to it, so that's why it's a triangular prism. But the same thing applies. If I can find the volume of this whole thing and then I can take out the volume of that triangular prism, I'll know how much volume is left. So piece by piece, calculate the volume of the right rectangular prism. Start with your formula. Volume equals the area of the base times the height. Now, since this is a rectangle, the area of a rectangle is length times width. So rectangular prisms are easy to find the volume for because our volume is equal to the area of the base, which is a rectangle, so length times width times height. Don't overthink it. So we're looking at this figure here. My length, I'll say, is 10 times my width, which is 10. And again, it doesn't matter if you say those are, we're all multiplying, so it doesn't matter the order. Times our height. Height is the distance between the bases, and that's 12 and a half. And I'm just going to write it as 12.5. Okay? Calculator. 10 times 10 times 12.5 is 1,250 cubic centimeters. Okay? So we could take 1,250 little tiny 1 by 1 by 1 centimeters, and that would give you the volume of the whole thing. Next step. Okay, just like we did where you find the volume of the whole thing and then find the volume of the inside piece. This time, we're going to take the volume of a triangular prism. So guess what? Formula is the same. Area of the base times the height. Now in this case, our base is a triangle, and that's what they give us right here. Right? They're trying to give you it says top view, right? So if you're looking down at it, that's what the triangular piece looks like. Triangle on top, it's got the column going down, triangle at the bottom. I'm going to be honest, when it's not a rectangle or a rectangular prism or rectangle base, I tend to draw a picture. Okay? Now I know it's up there, but maybe if I bring it down with this problem, it'll help us see, and it's obviously not a good picture. This is 5, this is 2.5, right? And it does say that this is 5.6. I'm not going to write that down though, because remember, I want just the right angle. Because my area of the base, area of my triangle here, remember, is base times height divided by 2. And how do we find the base and height? We look for the right angle. Okay, so right now they don't tell us the right angle, we just kind of got to go by how it looks. So not worried about that 5.6 right now. So here I am going to go 5 times 2.5 and divide it by 2. And I get 6.25. Okay, so when I go to my volume formula here, my area of my base, my triangle, right, is 6.25 times height. Now our formula says capital B is the area of the base, H is the distance between the bases. So how far apart are my triangle up here and my triangle down here? How far apart are they? In that really bad looking line. How far apart are they? Okay. Well, that's from the top to the bottom of the rectangular prism. So they are 12.5 centimeters away. And again, I'm going to write it as 12.5. Calculator. Okay, and that works out to be 78.125. I know you can't see it, but that's what I get on my calculator. It's volume. So again, it's cubic centimeters. So calculate the volume of the material remaining excuse me, in the rectangular prism. So if I have this rectangular prism, this box, and I take out this triangular section, this triangular prism, what's left? Well, just like we did in that picture frame type problem, we're just going to subtract them. So I'm going to take 1,250, my total volume, and I'm going to subtract the part of the middle I don't want, 78.125. Okay? Type that into a calculator, and you get 1,171.875. And again, this is volume, so it's cubic centimeters. Same process, just a little more work with the formulas, but don't overthink it. And please, 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 please use these formulas. Okay? All right, one last problem. We want to, what is the surface area of the triangular prism? Assume there is no top or bottom. Okay, so our surface area is really just our lateral area. Okay, assume there's nothing on the top and nothing on the bottom, right? Because this is kind of a hole in it. So it's going to be a challenge, I know, for me to draw it. So squint a little bit. All right, so I'm going to see if I can kind of get it right. Oh, nope, don't. Grab the wrong one here, right? Okay, so don't look too hard. Okay. Or squint, I should say. And if you are struggling to draw this too, don't even worry about it, because obviously I am. Okay, so we're going to kind of leave it like that. Poor effort, but we're okay. And we want the surface area of this. But, okay, we're going to assume that this is empty and this is empty down here. So we have the shape of our base, right? Now you can think of this a couple different ways, okay? We can find the area of each one of the faces and then add them up, and that's totally okay to do. With rectangular prisms, that's probably how it's the easiest way to do it. But now I'm going to bring in this 5.6 into play. Okay, so 2.5 and 5. Remember, right? 2.5. This is 5.6. And this is 5, I believe. 5.6, 2.5, 5. Okay, so remember, our formula for surface area is our lateral area plus 2 times the area of the bases. But we're assuming there's no top and bottom. There is no bases. So basically, I just need to figure out my lateral area. That's why it's a little easier sometimes to do the formula for this. So that's the perimeter times the height, the distance between the bases. So our perimeter here, just add them all up. 5 plus 2.5 plus 5.6. Okay. Calculator. Type the correct numbers in, it helps. Okay, and I get 13.1. 5 plus 2.5 plus 5.6. Okay, so my perimeter is 13.1 times my height, the distance between the triangles. Well, again, how far apart are the triangles? They're 12.5 centimeters. So take my calculator, 13.1 times 12.5, and I get 163.75, because I'm not adding the two bases on, because there's no top and bottom, right? And this was centimeters. So again, surface area is square centimeters. So in this case, the formula kind of came in handy, especially since we got rid of some part of it. Again, you could totally have found the area of each of these rectangles by using the pictures above, and then add them together. That works too. Okay, but the big difference is just kind of knowing the difference between what surface area is and what volume is. And when we have volume of the whole thing and we want to take away a part, we treat it just like we did with area.